I guess lunch hasn't come, and we're going to move on ahead. I want to just talk a little bit about DEMs. Okay, so DEMs are, well, first I want to talk about what DEMs, whenever I talk about DEMs, what is a DEM, I want to talk about what that means. And we're going to talk about some of the formats and some different ways of getting DEMs and using them in WMS. So, we're talking about DEMs, and first we're going to talk about DEMs, then we're going to talk about DEM-based delineation. So first we're going to talk about DEMs in general. If I want, thank you. If I want to go have a survey or go out and collect some elevation points, and this is a map, this is an aerial photograph, so I have these mountains here and then some valleys down here. Which points is the surveyor going to collect? Which points would you want? Yeah, so you want wherever there's some kind of change in elevation, right? And so you want your peaks, you want your valleys, and then anywhere there's some kind of change in elevation, you're going to get those points. A DEM, so this is just XYZ data, but a DEM is stored as a grid like this. So we may or may not be able to get those points that are wherever the elevation changes. So it may not get those points. We have two kinds of elevation data that we use in WMS. One type of elevation data is a DEM. So gridded elevation data is called a DEM in WMS. Another type of elevation data is just XYZ points. That's called a TIN. TIN stands for Triangulated Irregular Network. And so gridded XYZ points or XYZ points that are not associated with any grid, they're just scattered. We connect those by triangles, and that's called a TIN. Why do we connect the points with triangles? Why do we need to do that? Yeah, so you can have a continuous surface, right? So with DEMs, they're gridded elevation data, and if I have a DEM, I don't know if you can see these points, but if I have this DEM and these red points are wherever I have elevation data, is this going to be accurate enough to delineate watersheds in this area? Maybe, maybe not. We don't know. But I can increase the resolution of my DM so I can add more points. And at some point I'm going to get to the point where I have enough points that I can accurately delineate a watershed in this area. And so I could end up with this. This may be too many points. You could end up with too many points. If you have too many points, your computer is going to bog down and things are going to take a long time. So you have to find a kind of a balance between too few and too many points. DEMs are gridded data, gridded elevation data. TINs are XYZ points, just scattered XYZ points that are not set to any grid. So anytime I read in just scattered survey data, then it's going to be as a TIN. Anytime I read in some kind of gridded elevation data, that's a DEM. There are several formats that WMS supports for elevation DEM data, and these are some of the formats that WMS supports. We'll be able to read in any of these formats, and really almost any format that people have, we should be able to read in if it's gridded elevation data. And there are a few ways of getting DEM data. So one way is if you have a DEM file, you could read the file in. Another way is if you have if you want to, you can use the get data tool, the get data from map tool, and that's what I showed you this morning for the Sinai. And you can use the get data tool and get data from that. There's kind of two get data tools. Let me show you these really quick. One of the get data tools is if I don't have any data in WMS, then I would use the get data from map tool. And if I use that tool, I can select an area and download the data for that selected area. If I Why isn't it registered? Do you guys have that same problem?
No. Because this one I use this zone, the key. I use the key for this
So I need to use a hardware lock?
Yeah, at the beginning.
Where?
What is it?
Oh, you had it plugged in at the beginning?
Yeah, I think it's just a way
Well. Yeah.
Did you register?
I probably ought to just use a password on this computer, but it's okay. We'll do it later. I got the dongle. So all right, so there's two ways of getting elevation data from WMS. One way is get data from maps. So let's select this option, and we'll just use this. Select this area. So you can go wherever you want. You can go to Cairo if you want. Here's Cairo. And then WMS, I select the area that I want. So I go to however, zoom in as close as I want or as far out as I want, and hit OK here. And then WMS is going to bring up this window. And the only way to get elevation data for this area is use the SRTM. So I'll use the SRTM and we'll download this elevation data. CAIRO. So I'll just download this elevation data for this area, and it's going to ask me for a resolution. And like I say, the SRTM is about 90 meters, so I'm just going to enter 90. If you enter something smaller, WMS will resample that elevation data. So you'll have additional points that you probably don't need because it's only 90 meter data anyway. Yeah, if you hit OK, and then there will be an option to download different kinds of data. Okay, so that's how I can get the SRTM data. Another way to get data is you can use, if I have data that's already in WMS and my projection is defined, I can use this get data tool, and I can just drag a box around the area where I want to get data and select the type of data I want to download, hit OK, and we'll download data for that area. WMS resamples. So it'll prompt you for a resolution, and if you enter something lower than 90, then it's going to resample those points from the online data source. And so you'd usually want, for the SRTM data source, you want the data to be, its maximum resolution is 90 meters, but WMS might prompt you for a lower resolution. That's because it has a default resolution. In that case, you just change it to 90, because that's kind of your maximum resolution. Or you can download the resampled data. It really doesn't matter. It just takes longer to download if you download the resampled data. So now I have these two DEMs. One of them I got using the get data from map. The other is the get data tool. And the get data is if you already have an image in WMS, you can select the area that you want from inside WMS and get the data for that. So that's the difference between those two options. You can also use online. You can get your data from online sources. So there are different websites. Let me show you one website. So there's a website, there's a type of data called Aster. So if I go to Google and search for Aster GDEM V2, and then click on this first link that comes up. This is the, so Aster data is from NASA, from the U.S. National Aeronautics Space Administration. They went and figured out the elevation data in the entire world, and they have saved this online. I usually use, so I just search for Aster GDEM V2, and then I go to the first thing that comes up, and this second data source, this LPDAAC Global Data Explorer, I like to go there. It seems like the most useful site, and it will, and this is probably going to take a long time to download, but it brings up a map of the entire world, and you can select the area where you want to download data. You create an account on this website, select an area where you want to download data, and then you can download data for that area. And that's how I got this other map that is in Egypt. So this Aster data. Let me try that again. So here's the Aster map. Hit yes when it prompts you with that message to open it. Pardon?
Are you opening now select image or
This is I'm opening it as an image. I'm opening this file as an image. And so this is the Aster DEM data. I'm just opening it as an image though at first. Okay, if I want to convert this to a DEM, so this is the file right here, and it's under GIS data as an image. If I want to convert that to a DEM, I can right click on it, and then there's this option to convert it to a DEM. Now I'm not going to do that because I know it's going to take a long time. It's a huge file actually. It's a TIFF, but it's also it's an elevation grid that's stored as a TIFF file. And you can just open it in the GIS module, right click on it, convert that to a DEM. So that's how you do that. Once you get something as a DEM, then you can delineate the watershed for whatever it is, whatever area you've downloaded. This is 20 28.64 meter X and Y cell size. So it's 28 meter resolution. This is the original data here, and it's 28 meter data for this area. It might change depending on where you are in the world. That's right here. That's where it is. Yeah. So it's a little bit better. I downloaded it from this Global Data Explorer website. It's Aster GDEM V2 data.
What is the difference between, because when I open it, Aster Global Data and Aster Global DEM V2. So we choose V2?
V2. Uh-huh.
The recent one or something?
The V2 is version, V is version, so it's version 2 of the Aster data. And this file, so the one with the Nile Delta, you can kind of see the Nile Delta here. It's on your little memory stick. It's under the Aster. Under Egypt, there's a directory called Aster, and so you all have this. So you can just use this, or you can download it for whatever area you want. Or if you want to do it in Sinai, whatever. I'm not sure whether this is great data for watershed modeling. Like if I zoom into this, you can see that it might have the tops of buildings and things like that. So it might not be the best data for watershed modeling, but you can look at it and use it however you want to use it. So let's continue on here. So ArcInfo DEMs are also available. That's ArcGIS data. You can read those in. You can tile DEMs together. You can trim DEMs. So like this DEM, this is the whole Sinai. After I convert this to a DEM, there's an option to trim the DEM. Let me show you the option to trim, how that works. So here's and the other thing, one thing that's kind of newer in WMS is you can have more than one DEM. It used to be you could only have one DEM. Now you can have more than one DEM. And you can, if you have multiple DEMs and they're for different areas, you can right click on those, select both of them, then you can merge those DEMs together into a single DEM. But I'm not going to do that. So here I have these two DEMs. And the other thing is there's only one active DEM at a time. The active DEM is the DEM that's displayed. You only display one DEM at a time, and it's also the DEM that's used for all your watershed modeling computations. So I have this DEM and this one. Do you have a question?
For your notes, you said that you cannot more than one game more than one game. So can we do mosaic like that?
Can you what?
Mosaic?
Mosaic? Yeah, so you can merge the DEMs. So if I select multiple DEMs, I can merge those DEMs by right-clicking Merge DEMs. That'll combine them all into a single DEM. You can also, if I have DEM files and I'm reading those in, just using File Open in WMS, it brings up a window that allows you to tile DEMs together. And I'm not going to show you that, but there's a workshop, a DEM workshop that shows you how to tile DEMs together. What I do want to show you is how to trim a DEM. So let's say I have a large area and I want to trim that DEM. I can right click on the DEM, go to trim, and I can trim it using a polygon. And then you just point and click and create a polygon like this. And then that'll trim the DEM. Okay, so that's how you trim a DEM. And then, so now I have a third DEM, and that's the trimmed DEM. I can delete the original DEM if I want. Okay. Another thing about DEMs is they have no data points. No data points are there because most DEMs, all the DEMs they're always stored as a rectangle, some kind of rectangle. Sometimes you might either trim a DEM or the DEM might be at an angle, and you need no data points to define data because your DEM has to be stored as a rectangle. So when I trim a DEM, all these brown points here are called no data points. All the ones that are along the boundaries. Those are my no data points. And I can turn those on and off, but usually you're just not going to worry about the no data points. There are several display options for DEMs. You can do linear contours. You can also do color contouring. And you can go to the DEM display options, do color contouring. So there's my color contours. You can do shading. You can shade your DEM like a hill shade. So I can go to my display options, turn on lighting, shading, and that kind of does some hill shading. And you can change how it's hill shaded, stuff like that. But there are different options for DEMs. That doesn't look very good. Let's try that. Anyway, you can play around with the display options. There's also something called the display step. And the display step is means if you do 1 for the display step, that means every cell is displayed. If I do like 10, we're going to see what happens. So we'll change this to 10. It just makes it so the DEM becomes more pixelized. It just changes your display. The computations aren't changed, it's just your display that's changed. I'm going to leave it. You can do color and black and white hill shade. What's the right resolution for your DEM? Well, you don't want to be too coarse, otherwise you end up with a blocky watershed. You don't want to be too fine either, otherwise you have too much data. And you might want to smash your computer like this guy right here. And we've already talked about where to download DEMs. You can go to this website. XMS Wiki has this geospatial data acquisition website, GSDA. It'll give you a place for downloading DEMs. And this window will come up, allows you to tile DEMs if you read them into WMS. Some types of formats do not bring up this window, and you can just merge those DEMs together if you need to. And there are some different options. There's a thinning factor, an elevation units you can define, and WMS will smooth your DEM. So there are a lot of sources for DEMs, and I've already kind of shown you some of the options that are available for DEMs. How are we doing with lunch? Are we still waiting on it? It's okay. It's okay. We can keep going. Is everybody okay if we keep going? Okay. No, I'm okay. Let's keep going. We need to get through this stuff. So.
Great stuff. If you would like to switch up for like 15 minutes and when the lunch arrives, will it just 1 hour, or will you prefer to wait?
Let's finish this because this kind of goes along with DEMs, and then we'll break for lunch. So this won't take very long. So I wanted to talk about watershed modeling with DEMs, and we're going to learn how watershed modeling is done with DEMs. There are certain things we need to know about, and so we're talking about DEM-based watershed delineation now. We know where to get DEMs now, right? Do you all know where to get your DEMs? You either get them from WMS or you get them from the Aster GDM v2 website. So we know where to get them. Now we need to know how to use them. And DEM-based watershed delineation, excuse me, we already learned about map-based. We learned about map-based watershed delineation. DEM-based delineation is an automated way of doing map-based watershed delineation. You still do your map-based, when you do DEM-based watershed delineation, it'll create a map-based watershed. It'll create data in the map module in the drainage coverage that your points, your arcs, your points represent your outlets, your arcs represent your streams, your polygons represent your basin boundaries. It's just an automated way of doing it. That's DEM-based delineation. We're going to talk about, I'm not sure whether this is on our schedule, but I think we're going to talk about some advanced options where you actually combine your map-based delineation and your DEM-based delineation. That's what you were kind of talking about, that you can take your map-based, your DEM-based delineation, you can modify that DEM-based delineation to include any changes in your watershed. So let's say these are my well, first we need to talk about how a watershed is delineated automatically. Okay, maybe all of you, do all of you know about this, flow directions and flow accumulations, or did somebody not know about this? Maybe I should tell you about it. Okay, so first of all, there's flow directions, and flow directions is they are the direction of flow, just what it says, direction of flow in each cell on your DEM. And let's see, I'm not sure the best way to explain this. I usually write it down on a board or something, but okay. Do we have a marker for that board? Okay, I guess we could do this. We could do a pen. Alright, let's try to do it here on the screen. Okay, so let's say that I have this grid here, and this grid has a bunch of elevations on this grid. So this elevation here is maybe 9, this is 8, this is 7, these are my elevations, 6, 5, 4, 3, 2, 1. Okay, so those are my elevations on my grid. If I put a drop of water in this cell, the cell with an elevation of 9, where is the water going to go? Yeah, it's probably going to go wherever the highest slope away from that cell. So it'll probably go to 5, right? So let's draw a flow. The flow direction from that cell is to 5. How about to 8? Where's that going to go? Yeah. How about 7? How about 6? 5? How about 4? How about 3? It's going to go to 2, and then 2. And then where's 1 going to go? Probably nowhere. It's going to just stay there. So that's the lowest elevation, right? So everything's going to go there. Okay, so let's, these arrows are my flow direction grid, right? That's called a flow direction grid, those arrows. And usually on a computer we're going to represent it as a number. So in this case my numbers are these numbers, each of these numbers represents a flow direction. And so like for this cell, I'll look at all the cells around it and it'll go to the lowest cell. So for each of these cells I compute a flow direction. That's my flow direction grid. My flow accumulation grid, so let's do the same thing here. If I look at this cell here, how many cells flow into that cell? Well, I guess I gave away the answer. It's 5. How about this cell right here? How many cells go into that cell?
1.
This one right here. 5 plus, yeah, plus this one, so 6. How about this one, this next one? 5, 6, and then I got this one, 7, 8, 9, 10, maybe 10, 12, I guess. And then so I can keep going down and I get this grid that has, each cell has a flow accumulation value. And so that's called a flow accumulation grid. Wherever I have the highest accumulations, those are my streams, right? And I can change the stream threshold. So here it's 1 value, and then if I lower that threshold, then I'll have more streams. To delineate a watershed, I define an outlet point, like this one, and then WMS will figure out where my watershed boundary is. So something like this. It's here. Okay. Okay. That's. Yeah. Let's take a break. And so it looks like we're going to start up at 1:45. Take a break for an hour.
This
is yes, this one. Why one here goes to this one? Not from here to here.
This one goes to this one.
No,
and not
this one goes to this one. Why? Why not? Why not the other way?
Why doesn't this one go to here or something?
No. Yes, here this point 1 goes to this point 1. Why it doesn't go to the other?
Oh, why doesn't this go up
yes,
here?
from 1
Okay.
to 1.
So it just depends. It's because that's just how the model is. That's, if you look at like all the surrounding cells, that's kind of where your maximum slope is. So it could be because these elevations in this area are higher and then these are lower elevations. And so in general, that's the way the flow is
not
going.
just think 1 point from 2 points.
Yeah.
But it takes in consideration the area around it.
Yeah.
Okay.
The topaz does, and actually most of the, there's topaz and then there's tau DEM. Oh, I probably shouldn't have kept. Anyway.
Okay, I get it.
Yeah.
So we take in consideration the area around it and the elevation around this point, not only from north to south.
That's right.
Thank you.
This we're going to have a break from quarter to 1 until quarter to 2.
Yeah. Is that okay? Is that too long?
No.
Okay.
That's you. But you have to tell everybody we will be back, so we should be here at
Okay.
that time.
All right. So yeah, we're gonna start up at 1:45 next. Just so you know. Probably need to